Today we're going to look at how to implement transportation policies in the Osmosis ClicSAND software. The first thing you're going to do is you're going to go to the Zenodo deposit, which is linked in the video down below. Next, you can scroll down and download all these files. The first file we're going to look at is the Energy and Flexibility PDF. Once you open that up, it'll look at a document like this. We can first scroll down and look at the learning outcomes for today's activity. First, we're going to review how transportation is modeled in the ClicSAND software. Next, we're going to look at how to apply an electrification policy to a single transport demand. And lastly, we're going to look at how to apply an electrification policy to an aggregate of transport demand. This means applying an electrification policy to two or more demands. First, we're going to look at how transportation is modeled in ClicSAND. There are three different types of transportation demands in ClicSAND. There's car transport demand, there's motorcycle transport demand, and then there's demand to service both bus and rail service. If we look at the reference energy system of the energy flows for transportation, it looks like what's shown in Figure 1. Notably, the light fuel oil can service gas cars, gas motorcycles, and gas buses and trains, while electricity can service electric cars, electric motorcycles, and electric buses and trains. If a transportation demand is electrified, the electricity must pass through an EV charger, which will have its own capital cost and efficiency. Finally, each demand, separately, can be met by a mixture or a single value of the electrical or gas counterpart. For example, car transportation demand can be met by solely electric vehicles, solely gas vehicles, or a mixture of gas and electric vehicles together. First thing we're going to do is we're going to run a reference scenario to see how the transportation sector naturally behaves in our current model state. So the first thing we're going to do is we're going to make sure we have installed ClicSAND and know how to use the Osmosis Cloud platform. And then we're going to select a starter kit and run the model and view the transportation results. You can follow along with this exercise by using the base and ClicSAND file provided in the Zenodo deposit. So I have converted this using ClicSAND software. I've uploaded it to the Osmosis Cloud platform, and I have run a reference scenario here. I've downloaded the results and converted them and using the results template to view the results. I select the transportation sheet once importing the results, and I refresh the graph. And these are the results I have. The next thing I'm going to do is in the Zenodo deposit, there's a file called results helper. I've opened that up and I've copied over the results. So, for example, in my results template, I have gas motorcycle production for 2015 through 2020, and that is the same production I have here. I've just copied over the results. And we're using the results helper template in the Zenodo deposit to be able to effectively compare scenarios. Once I've copied over all the results, I can view the graph here. And I can see there's a mixture of gas and electric motorcycles, gas and electric buses, and then all the car transportation right now is via gas cars from 2015 through 2050. I've now run my reference scenario. I can move on to the next step. Next, we will flip back to the exercise and we'll scroll down to the first scenario. And this is where we're going to implement an electrification policy for cars only. So if we look at current results, such as Figure 2, we can see that from 2015 to 2050, the car demand is basically met by only gas cars. We want to implement a scenario where we start to force electric cars to enter the system. And what that looks like is shown in Figure 3. We are going to define a curve, such as the red line shown, that is going to say for each year, what share of car demand must be met by electric vehicles. To do this, we will go back to the Zenodo deposit and we'll make sure we have downloaded the demand helper Excel sheet. Once we've done that, we can come back to the exercise And we can see there is an equation here, which is just a linear line equation, and we're going to use that to define the red curve. On the demand helper sheet, if you open it up, it'll look something like this. This equation here is the same one shown in the exercise sheet. And this will just help us calculate for each year what share of which share of car demand must be met by electric cars. So we know from 2015 to 2019, we don't have any policy on. So we know our electrification share will be 0. And then starting from 2020 onwards, we want to start implementing this equation. And before we type that out, we'll first fill in our parameters. So we know our starting electric share is 0, our ending is 100, our start year is 2020, and our end year is 2050. So by 2050, we want 100% of car demand to be met by electric vehicles. In this cell, we can then type in this formula. This will equal the electrification share at the end, which will be 100, and I'll lock that reference, minus the share at the start, which is 0, and I will lock that reference. This is divided by the end year, 2050, minus the start year, 2020, multiplied by our year in question, which will be the value in A7, then minus the start year, which is 2020. Locking that reference. And then we're going to add in the share of electrification at the start, which is 0. So we know in 2020, our policy is just starting, so we don't have any sort of limit. But if we carry this formula down, we can see that it gradually increases until in 2050, 100% of car demand must be met by electric vehicles. Next, what we're going to do is we're going to go back to the Zenodo deposit, and we're going to look at our reference model that we ran in the previous scenario. We'll open that up, and then we're going to look at the accumulated annual demand for the fuel transportation cars. So this is our car demand. We're going to take the values from 2015 all the way over to 2050. We're going to copy those, and we will paste them into our demand helper as transpose. From these two values now of our electrification share and our total car demand, we can calculate what amount of production must be met through our electric vehicle technology. And just as a reminder, we are setting the amount of generation that must come through the electric car technology. So this is the first yellow box, the upper yellow box, to meet car transport. So by 2050, all car transport must be met by electric cars. To do this, we can use this formula down here, which is also in the Excel sheet, and that's calculated for you already. This also rounds the number just to avoid numerical issues in the model file. From here, we can then go back to our model file. We can remove the filter for fuel. And we can search for the parameter total technology annual activity lower limit. So this will set the amount of activity a technology must perform in every single year. This will be a minimum generation constraint. We can hit OK. And then we can filter for our technology, which will be transportation demands for car, and we want that as an electric car. So just that first one, we can hit OK. We can then go back to our demand helper. We can get these values. We can copy them, and then we'll paste special, and we'll do values and transpose. We can hit OK. And then we can see from 2020 onwards, our minimum activity from electric cars gradually increases until 2050, where all car generation, which is 680 petajoules, must be met by car demand. Or electric car demand, sorry. Next, we can use ClicSAND to generate a osmosis cloud data file from this model. We can then take that and upload it to the osmosis cloud platform, run the model, which is car electrification here, download results, use a conversion tool, and view the results in the result template. Once doing that, I'll make sure my graph is updated and I can view the results from my 6 different transportation technologies above. Like our reference scenario, I will copy and paste these columns into our results helper datasheet, making sure I am now on the car electrification scenario, and I'll populate these first 6 columns. Next, I'll make sure and double check that my share of electric vehicles is correct. So first, I'll calculate the total car demand from the results, and that'll just be the sum of the gas car demand and the electric car demand. And then I'll carry that calculation all the way down. And then I'll calculate the share of EVs meeting this demand. So that will equal the amount of electric cars on the road divided by the total amount, and then we'll change it to a percentage by times by 100. And then we'll carry that calculation all the way down. And we can see that by 2050, we are meeting 100% of car demand through electric vehicles. Moreover, we can see that the switch to all electric vehicles happens closer to 2035 now. We can then scroll down below and we can plot these results. So first is the transportation generation by source. So this is very similar to our reference scenario graph. And we can see that electric cars in the dark gray at the bottom starts off at meeting 100% of demand, but by 2021, electric vehicles begin to enter, and then by 2035, the vast majority of electric vehicle demand is met by electric vehicles. Moreover, we can plot the share of electric vehicles on the road. So we can see 2020 to 2034, the amount of electric vehicles follows the linear line we defined, and then the model decides to invest more into electric vehicles than our minimum amount required. So our model is behaving as expected. Finally, I'm going to come back to the exercise. I'm going to go to the last policy. This is the electrification policy for an aggregate transportation demand. So in this case, we want to electrify the car and motorcycle sectors together, but we don't necessarily care if cars or motorcycles are electrified first. We want to let the model decide that. So what we're going to do is we are going to implement what is shown in figure 6. We are going to first create 2 dummy technologies and 1 dummy fuel. If you have not done the dummy technology exercise, I encourage you first to go back and review that. The 2 dummy technologies are going to be responsible for tracking the aggregate generation from cars and the aggregate generation from motorcycles. We need these dummy technologies to make sure we do not overproduce generation from a certain sector. We are then going to also create a dummy demand, which is TRA-CAM-DMY in this figure. This dummy demand will track the aggregate electrification share. To implement this in ClicSAND, all the steps are down below. Moreover, in the Zenodo deposit, under the Data Helper Excel file, you can download that and you can view all the changes in values that's going to be walked through in the exercise. What we're going to focus on is how we come up with the values for accumulated annual demand and the total technology annual activity upper limit values. So first, if we come back to the demand helper and we go to the car and motorcycle sheet, we see it set up very similar to how we had it for the car sheet. These equations are also shown in the exercise. The first thing we're going to do is calculate the shared electrification share. So we know for 2015 through 2019, the electrification requirement is 0. And then from 2020 onwards, we want to implement this formula, the top one. First, we're also going to input our parameters. We know the electrification in the start is 0, at the end will be 100, the start year is 2020, and the end year is 2050. Zoom out so we can see the equation. So this will equal electrification at the end, lock the reference, minus electrification at the start, divided by the year at the end, 2050, again locking the references, minus the start year, 2020. Then we will multiply it by the year in question, which will be the value in A7 in this case. We'll leave that as a floating reference, and that'll be minus the start year, which is 2020, locking the reference, and then adding in the start electrification share, which is 0%. And as expected in 2020, the electrification share is 0, and if we carry that all the way down, we can see in 2050, it's 100. So that's great. We will get our car demand and our motorcycle demand. So back in the ClicSAND sheet, I have filtered for the parameter accumulated annual demand and the fuels for motorcycle and car demand. I can then grab these values and paste them into our demand helper. So 2015 through 2050 for this one is motorcycles. I'll go back to the demand helper, motorcycle demand. I'll paste special as values and transpose. And then I'll do the same for cars. Paste special adds values and transpose. Then in column G, I have summed the two demands together. So this is just our car demand plus our motorcycle demand. And then in column H, it is our combined demand multiplied by the electrification share. So for example, in the year 2050, our combined demand is 996 petajoules. Our electrification share is 100%. That means the amount of generation into our dummy technology has to be 996, the same as our total demand. So all formulas are making sense in this sheet so far. We can then use this value to fill in the accumulated annual demand for our dummy commodity. So if we look back at the exercise, we have our dummy commodity here, and this tracks the electrification share of the aggregate of electric cars and electric motorcycles. So if we look at our data helper, we can see that the accumulated annual demand for our dummy commodity is the values we just calculated in our demand helper sheet, with the 2050 value being the 996 petajoules. Next, we will look at how to get the total annual activity upper limit for our two dummy technologies. We need to enforce annual activity upper limits for these dummy technologies to ensure that the ratio of car demand to motorcycle demand remains the same. To do this, we will just implement the total demand as the annual activity upper limit for each one. So the car transport demand will be the total annual technology activity upper limit for all car dummy technology. So we can see in our demand helper, for example, our car demand in 2015 is 351, and we rounded up just to avoid numerical issues, so 352, and we'll copy these values in for the total technology annual activity upper limit for cars. So we see the 352 again there. And these values will go all the way over to 2050. You have gone through and you've updated your reference scenario to implement all these changes. You can then use ClicSAND to generate a Osmosis Cloud input file and run the model on Osmosis Cloud. Once you've run the model, instead of this time just downloading the result file, you need to download the result CSVs. We cannot use the result templates to view the current results in the aggregate demand. So once we download the result CSVs, we can open up the CSV folder and we'll look at production by technology annual. Next, we will apply a filtering to the table, and then we will look at each technology individually. So for example, if I look up the demand for cars, TRA, CAR, I have my gas and electric. So first I'll look at the gas production. And I'll make sure to filter for only my dummy technology, or dummy fuel. So I only want to track these fuels, the one shown the yellow and the black and the red, not the turquoise color. So again, I only want to look at the TRA, CAR, DMY fuel demand or production. I will then copy these values and paste them into our results helper, which would be over here. I will repeat the process for each technology. Finally, we will look at the amount of demand being met by electric cars, electric motorcycles, and the combined electric cars and motorcycles. To start, we'll figure out the total aggregate demand, which will be the sum of all gas and electric motorcycles and cars. And we'll carry that calculation all the way down. We will then figure out what percentage share of electric cars is meeting this aggregate demand. So this will equal the amount of generation from electric cars divided by the total times 100 to turn it into a percent. We will do the same thing for motorcycles. The amount of electric motorcycles divided by the total times 100. And we can carry those all the way down. And then we can calculate the total share, which would just be the two summed together. And we can carry that all the way down. Once we've done that, we can then go view our result graphs at the bottom. So here is the production of our aggregate motorcycle and car electrification policy. And then below that, we can see the share of electric vehicles and motorcycles on the road. So we can see in 2020, electric motorcycles fully electrify. And we know that because it's a straight line from then on out. And then we can see from the blue line, as we hit 2026, our policy starts coming into effect. And then we see a sharp jump up. And then we can see the blue line carry all the way through. And then we know that the green line shows the sum of them both. So we can see in 2050, 100% of aggregate car and motorcycle demand is met by purely electric vehicles and motorcycles. And with that, we can come back to our exercise and we can review our learning objectives. So the first thing we went through is we learned how transportation is modeled. The second thing we went through is how to apply a single policy to a single transport demand. And then finally, we went through how to apply a policy to aggregate transport demands. So it'd be how to electrify cars and motorcycles together. Good luck in implementing transportation policies in your model.